Hi everyone, welcome back. So today we'll continue with differential equations. So in differential equations, so far we have discussed solving differential equations which are variable separable or which are homogeneous differential equations or which are linear differential equations. We have also discussed in detail Euler's method where we don't actually solve a differential equation, but we can find a numerical solution of that differential equation. Means we can find value of dependent variable when the value of independent variable is given. Now next is we have also discussed Maclaurin series. So continuing, we will see how do we express the solution of a differential equation in terms of a Maclaurin series or a series developed, a Maclaurin series developed from a differential equation. So basically what happens when we solve a differential equation, we can express the answer as a series, a Maclaurin series. So the question is, can we solve all differential equations using Maclaurin series? And the answer is no. Um, a differential equation which has an ordinary point as x is equal to 0. So in an equation where x is equal to 0 is an ordinary point, that equation can be expressed in terms of a Maclaurin series. Now what is an ordinary point? So to make it very simple, ordinary point, you just check if the value of the function exists at x is equal to 0 and also the first derivative of the function exists at x is equal to 0. If these two conditions are met, we can express the differential equation as a Maclaurin series. So the checkpoint is value of the function and derivative of the function must exist at x is equal to 0. So if these conditions are met, we can express a differential equation, a solution of a differential equation as a Maclaurin series. Now, before we continue, I would like you all to recall Maclaurin series. This is the Maclaurin series, which is the value of function over 0 factorial plus first derivative of function at 0 over 1 factorial times x plus and so on, so forth. So let's explore it with the help of an example. So here is an example. Find the first three terms of the Maclaurin series solution to y dy by dx is equal to e raised to the power of 2y with initial condition y naught is equal to 0. So here we can see that value of the function is 1 when x is equal to 0. So when you put x is equal to 0 and y is equal to 1 in this expression, this equation, then dy by dx will have a value. So this differential equation can be solved in terms of a Maclaurin series. How do? We follow usual process. We find the value of function, first derivative, value of first derivative at x is equal to 0, value of second derivative at x is equal to 0, and so on and so forth. Then we write the power series. So let's start. So dy by dx is, from here you can see dy by dx will be e raised to the power of 2y divided by y. So value of dy by dx or y prime at x is equal to 0 will be e squared. Now you can differentiate this. When you differentiate this using quotient rule and chain rule, don't forget it's 2y, not dy by dx. And of course we are using implicit differentiation because whenever you differentiate y, you need to put dy by dx with that. And the value of the second derivative at x is equal to 0 is e raised to the power of 4. Now, the question says first three terms of the Maclaurin series. And what are first three terms? Here are first three terms: value of function, first derivative, and the second derivative. So we are done and we are all set to write the answer. So what will be the Maclaurin series solution to this differential equation? This will be first value of function over 0 factorial plus first derivative at x is equal to 0 over 1 factorial plus the second derivative at x is equal to 0 over 2 factorial times x squared plus and so on and so forth. So this can be written like this as your final answer. So this is how you express the solution of any differential equation where x is equal to 0 is an ordinary point in terms of Maclaurin series. So I hope this explanation was useful. If you like this video, consider subscribing it and sharing it. You can always reach out for more quick videos on different topics on mathematics. Till we meet again, take good care. Bye bye.